Hello everyone, welcome to today's tutorial. On today's tutorial, I'll be talking about a topic called ordinary differential equation, which is the ODE in short. But before we talk about this topic, there are some two paramount things you guys need to know. Everybody watching the video, there are some two things you need to know. Now, the first thing you need to know is what we call the dependent variable, and the second is what? Your independent variable. Let me list them out for you. Now, those two paramount things are being listed on the board. Now, we have the dependent variable and we have the independent variable. Now, what is the dependent variable? Now, the dependent variables are the variables that depend on other variables. Example, we have an equation. Y is equal to 2x plus 5. Now, before you resolve this to what is the dependent and independent variable, you first of all ask yourself, if I affect y, will it affect the whole equation? No. If you say y is 0 and the other side of the equation is 2x plus 5, it's not really affecting the equation. But if you affect x, which is, you said y is equal to 2 and x is equal to what? 0, it will affect all the equation. Y is equal to what? 0 plus 5, which y is equal to 5. This has affected the equation. So, what is your dependent variable and what is your independent variable? Now, from the equation listed, your dependent variable is what is depending on the other variable. Now, what is depending on the other variable? We can see that y is dependent on x. So, our y here is our what? Is our dependent variable. While the x is what? Is our independent variable. So we see that y is dependent on x. If you change the value of x, you have already changed the value of the equation. You've changed the value of y. You've gotten a new equation of y. Now let's take another example. F is a function of x which is equal to y. Now, if you are given an equation or if you are given a function to classify your dependent variable and your independent variable in the equation. Now, what you simply do is look at your equation. What is depending on another? When I mean what is depending is, what is that variable that depends, that without the other variable it will not exist. Now, if you check very well, your y is depending on x because the x is the function given, and they are saying the function x is equal to, that is bringing out this value. So since the function is portraying, that is giving out what is y is dependent on any function of a variable given. But the variable given there was f is a function of x which is equal to y. So now, what is your dependent variable and what is your independent variable? Now, your dependent variable is your what? Your y, because your y is depending on the function x. So y is our dependent variable, while our what? Our x is our what? Independent variable. We've classified it to whether your function is your what? Your dependent, or your function is your what? Your independent. So that is how you classify your variables. Now, if we are given a function like this and they said, okay, since you are given this function, differentiate the function, then classify whether your function is a dependent variable or is an independent variable. What do you do? Now let's take that example. Now, if you are given a function f of x is equal to y, and we are asked to classify with the derivative your dependent variable and your independent variable. Now, if you are given a function like this, what you do is you differentiate the function. Don't forget, you're differentiating x with respect to what? Y. You are differentiating x with respect to y. Now, if you are given a function f of x is equal to y, and they said we should differentiate the what? We should differentiate before classifying to whether a dependent variable or an independent variable. Now, what you simply do is you go over to the differential of what we have on the board. Now, if you are differentiating, this will be what? The f, because it's our differential function. So you get the function differential with respect to what? Your dx, because it's the given function. Now, this is equal to what? You are differentiating y with respect to what? Your dx again. Now, classify to their dependent variable and your independent variable. Looking at the question first, what was your dependent variable? We know that y was our dependent variable. And what is our x? Our x is our independent variable. So what you simply do, you come over to equation. You can rule it out and rule this out. You rule this out. What do you do? You simply say these are what? These are our independent variable. This is your independent variable. Independent variable. This is your what? Your dependent variable. So that's what you simply do. So you've gotten your dependent variable and your independent variable. Now let's take one example under an equation. Let's take one example under an equation. Now let's say we are given an equation. Now, if we are given an equation and we are told to classify to our dependent variable and independent variable, what do we simply do? What we do first is we check what is the two variables given. We have the x and y variable. You ask yourself, in this variable was given in function that we classify to a derivative function. Now, what is the one attached to the function and what are we differentiating with respect to? Now, if you check very well, on our previous example, I told you your independent variable is the one attached with the function. Now, if you check what is attached with the function, if you try to bring out this function, what is the two functions? We have x and y. But previously, I told you the one attached to the function is your what? Your independent variable. Now, looking at it, what is the equation differentiated with respect to? You can see that the equation was differentiated with respect to y. So now, to classify whether the equation, your dependent variable and independent variable, what you simply do is you draft out your two variables y and x. Now, what is your dependent variable? This and this. This is your what? Your dependent. This is your dependent variable, while this is your independent variable. So that's what you simply do. So this is the two paramount variables you need to know before we dive into ordinary differential equation, which is the ODE. Now, still on ordinary differential equation, let's talk about order. Previously, we've talked about the dependent variable and your independent variable. Now, let's talk about what an order is. Now, what is an order? An order is the highest derivative in an equation. An order is the highest derivative in an equation. Now, before you know what an order is, you need to know what is called a derivative, the types of derivative we have. Now, we have the first derivative, which is dy over dx. We have what is called the second derivative, which is the 2y over dx. We have the third derivative, which is the 3y over dx3. We have the fourth derivative. If you are given the fourth derivative, it can be written as the 4 dx over what? Dy raised to the power of 4. Whichever way you are given, whether you differentiate with respect to x or y, whether you are differentiating with respect to b or c, whether you are differentiating with respect to any variable given, your derivative will be this way. Now, since you've known your derivative, now what is the order? Now, the order are these powers of d. Let's say powers of d, so you know what an order is. The powers of d. What is the d carrying? What is the derivative power? Now, if you check the first one, your power here is invisible 1, which is your first order. We have the 2, which is your second order. We have the 3, which is your third order. Then we have the last one, the 4x over dy4. Those are your what? Your orders. Now, they said if you are given an equation and you are asked to pick out your order in the given equation, what do? You look at the equation and you look at the derivative. What is the highest derivative you can see in your equation? Now, let's take an example. Dy over dx plus x plus 3 equal to 0. We are asked to classify the equation to order. What do? You look at your equation. How many derivatives are you seeing in the equation? We are seeing just one derivative. Now, the derivative we are looking at, what is the power of the d you are seeing in the derivative? Is 1, invisible 1. So, what is your order? Your order is what? Your first order ODE. So, this is your what? Your first order ODE. Now, let's take another example. You are given a complex equation like this, and you are asked to classify whether your equation is your now, if you are given a complex differential in this manner and you are asked to classify it to your order, you know what to do. Now, looking at the equation, what do you do first? You ask yourself, what are the derivatives I'm seeing? I'm seeing the second derivative and the first derivative. But we said what? Order is the highest derivative in the equation. Your highest derivative in the equation. Now, what is your highest derivative? Your highest derivative is this. Now, what is the order? Your order will be what? Your second order ODE. So, what do? You simply tell them your order is your what? Your second derivative, which is what? Your second order ODE. The equation is an second order ODE. Previously, we've talked about what is an order, what is a dependent variable, and what is an independent variable. Another thing we need to talk about is what is called the degree. Now, what is a degree? A degree is the highest power or your exponent of a derivative. Your highest power or your exponential power of a derivative. Now, let's take an example under what a degree is. If you have this, and you're asked to classify this to your what? Your degree, what do you simply do? Look at what are we talking about when we are talking about degree? We are talking about the highest power of a derivative, your highest power of a derivative. Now, When I mean your highest power of your derivative, look at your derivative. What is the power of each of your derivative? Now, looking at the derivative, we have this first order. We know that this is a first order, and we know that this is a second order. Now, what are their powers? What are their powers? Now, looking at the first derivative, what is the power? We are seeing an invisible one here. And what is the second one? The second derivative is having a 3 as a power. Now, what do you simply do to get your degree? Your degree is the what? Is the highest power or your highest exponential power of a derivative. Now, looking at the two derivatives we have, what is the highest power? We know that the second derivative is carrying what? A power of 3. So is our what? Is our highest derivative. So you are taking your order from your second derivative. So what is the degree in the equation? Now, the degree is the equation is simply what? Is in the third degree. So you've known what an order is and what a degree is. Now we are giving an example, and the example says what? Classify. The example, this is the example here. We want to use this example. Now the example says what? Classify the equation to what? To order and degree. To order and degree. Now, on our previous contents, I've told you what an order is and what is a degree. Now, what is an order and what is a degree in the equation? Now, looking at the equation, first thing you do is you classify your equation to order before classifying it to degree. Now, what is the order in our equation? I told you an order is the highest derivative in an equation. Now, what is the highest derivative in the equation? This is the highest derivative. We have the third derivative. So how do you now classify it? Now, the equation is what? We know our derivative, which is the order. So in our equation, we have what? The third order ODE. And what is our degree? In the highest derivative, what is the power of the highest derivative? Second degree ODE. So that is how you classify your equation to what? Your order and your degree. Now, still on ordinary differential equation. Now, let's talk about linearity and non-linearity. Now, if we are given an equation and we are asked to classify the equation or to look at the equation and tell if an equation is linear or an equation is non-linear. Now, classifying an equation to linearity and non-linearity, we have conditions. Now, if these conditions hold, then your equation is linear. Let's take the conditions. Now, for you to classify an equation to linearity and non-linearity, the conditions must hold. Now, if these conditions hold, then your equation is linear. Now, these conditions, the first condition is what? No product of dependent variable and derivative should exist. No product of dependent variable and derivative should exist. Now, what is the second condition? Every dependent variable and every derivative involved occurs in the first degree only. Every dependent variable and every derivative involved occurs in the first degree only. Now, let's take an example for more clarification. Now, we've seen the conditions given to know whether an equation is linear or not. Now, if those conditions hold, then your equation is linear. But if those conditions are not being held, then your equation is non-linear. Let's take an example. Looking at the equation being given, let's see if our equation is linear or not. what was our first condition? The first condition was what? No product of dependent variable and derivative should exist. No product of dependent variable or derivative should exist. Now, there's no product of dependent variable in our equation, which that conditions it's obeyed. The second one is every dependent variable and every derivative involved occurs in the first degree only. Now, let's take the second condition very well. They said what? Every dependent variable and every derivative occurs in the equation must be only on first degree. Now, looking at our derivative, we can see that your second order derivative, which is this, is obeying the law. Looking at the second derivative in the equation, which is this, is it obeying the law? It's not obeying the law because of the degree. The degree of the derivative is what? Is 3. But they said the degree should be only the first degree, which this equation is what? Is non-linear. Why? Because the y over the x raised to the power of 3. Now, if you write this down, any layman that knows what is linear and non-linearity will know that your equation is not linear. Now, let's take more examples for more clarification. Now, looking at your equation, is the equation linear or non-linear? Our equation is what? Is non-linear because we have a product of what? Our dependent variable. The equation is what? Is non-linear. Why? Because of y squared. Now let's take more example to determine whether your equation is linear or non-linear. Is your equation linear or non-linear? 1. We are not seeing any product of the dependent variable that exists. Now, the second one is the derivative given and your dependent variable in your equation is in the first degree. So your equation is what? Is linear. So we have what? A linear ODE. Now, since we've known what a dependent variable, an independent variable, an order, a linear equation, and non-linear equation, setting things in ordinary differential equation. Now let's put them all into practice. Now, if we are given an equation in this manner and we are told to classify the equation to order, degree, dependent variable, non-dependent variable, linearity and non-linearity, let's see if we can classify the equation to those patterns. Now let's take an equation. Now, looking at your equation given, you are all given in prime. And what does this prime mean? Your prime simply means your derivative. If you can see y subscript, it also means your derivative. So how do you know whether your derivative is in your first derivative, your second derivative, or your third derivative? For the prime, you look at the number of prime in your equation. Look at the number of prime of each y. You know your derivative. Now, for the subscript, you look at the numbers of subscript given on your y. You know the type of derivative that y is. Now, let's take the first one, which is y prime prime. Now, what is our y prime prime? We know that we have 1, 2, 3 prime. So, is in our what? Is our third derivative. So, we have what? The 3y over what? The x cube plus the square y over the x square plus the square y over what? The x square plus y plus what? The y over what? The x equal to 0. Now you've taken all your primes and your subscripts to a derivative. Now what do? First, let's classify whether your equation is linear or not before we move further. Now, looking at the equation, we know what a linear equation is. So looking at this equation, is the equation linear or not? The first one is we should not see a power of what? Our derivative, which our powers should be in 1. Now, in the given equation, our powers are in 1. So our equation is what? Is linear. So first, your equation is linear. Another is to classify your dependent variable and your independent variable. Now we know what a dependent variable is and your independent variable, and we have two variables in your equation. Now what is your y and what is your x? Now you simply say your y is your what? Your dependent variable. Your x is your what? Your independent variable. Now we've classified the equation to linear equation. We know what the dependent variable is. We know what is the independent variable. Now let's classify the equation to our order and degree. But before we do that, we'll first look at our order. Let's classify it to order first. Now classifying the equation to order, we simply look at your equation. What is the highest derivative there? Now to classify it to your order, you look at your highest derivative. And the highest derivative is what? The third derivative. So your order is your what? Your third order. Now, since we've known the order of the equation, let's talk about the degree. What is the degree in the equation? What is the degree of the equation? Now, your degree in this equation is your what? Is your first degree. ODE. So, in this tutorial, we've known what a dependent variable is. We've known what is an independent variable. We've known the order, and we've known the degree of the equation. We also know what an equation, when an equation is said to be linear and when an equation is said to be non-linear. Please subscribe and don't forget to hit the notification bell for more content like this. Thank you.